Hey everybody, it's David Emily. Hope you're doing well. I wanted to make a help video over Caesar for those that may be having troubles with it. Just going to walk through kind of how I did it or how I would do it. This is over drill weekend, my lunch break, so I'm going to try and make it pretty quick. This is also my first time ever recording anything, so if you have any criticism, constructive or not, let me know. Okay, first here at the screen, I actually don't have a Caesar yet, so I'm going to make the directory Caesar, if I can spell it right. And then I'm going to move into that directory. And then I think, luckily I took notes from the class that all I have to do is open Caesar C. Okay, so I'm going to open Caesar C. Cool. Alright, looks like we've got everything going. Let's start just by making sure it creates. So we all know that from there I need an int void main. Let's just make it like printf hello world, because that's just how this stuff works. You always have to do hello world and then make it return something. So let me make this and make sure it's not broken. It is broken. Oh, cool. So it looks like I just forgot to save, and I think actually, so error, hello world. Oh, I don't have any libraries. So let's start importing libraries, eh? Okay. So first library, we have include stdio for Studio. Let's see, that should fix our printf issues. Cool. It fixed that issue. While we're looking at the libraries, let's think of what else we'll use. This is CS50, and they have a lot of really cool libraries open for that. So let's include the CS50 library. I'm trying to think. We'll be working with strings, so let's include the string one. We'll probably be working with types, so let's include the types. And I think if we go to the manual page, it has pretty much all the functions that we'll use here. And if you haven't been there, it's the CS50 program, main.cs50.io. And they mentioned in the earlier walkthrough that we'll probably use this A2OI function, which is part of standard lib. So I'm going to go ahead and bring that in too. Alright. I'm going to make sure I didn't break anything by remaking this. Cool, it worked. So now let's start with the problem. So reading over this problem, I won't go into it here, but basically we want to allow them to pass in something through command line argument. We want to parse that and make sure it's good. We want to make sure that they're only passing in a number. And then after that, after we validate it, we will have them pass in a plain text string, and then by ever how many numbers they insert, we're going to increment that plain text string to make like a ciphertext string. So first things first, we need, let me delete this hello world because I hope it's still working. Let me try that actually. Make Caesar a.Caesar. Cool, hello world. So I'm going to go ahead and delete that. We know it's working. So first we want to read input from command line, CLI as some people call it. We want to parse. We want to make sure they only enter one digit, so we don't want them entering like an entire like number, comma, or space, number, or a giant string. We just want the very first thing they enter. So we're going to read only first command line argument. We want to parse that and return error if there's any characters or strings. So this is kind of like the first big step we want to do with this. So I think we first read in their input, parse it, and then decide if, and then we can read the later problem and go over working with the manipulating the actual string. So let's start off with here. They go into this over the walkthrough, the quick walkthrough before the thing. If you haven't watched that, I definitely recommend it. The walkthroughs before the homework are super helpful. But basically, we know they want to pass in. We know argc, when they pass in, there's like a, hold on, let me go over this real quick. There's an argv and an argc. So the argc, actually shoot, I think that actually needs to go up here. So the argc is how many individual items are actually passing in through the command line. And then the argv is going to be a string of what they're actually passing in. They go over this in the walkthrough, but if you ever see this in the program or outside world, that's what it means. I think that's pretty C specific. But anywho, so here we want them only to enter two variables. And there's two variables because one, they're calling the Caesar code to make it run, and then two, they're passing in a number. So anything more than that, and we want to return printf usage Caesar key. That is in the directions, and then if we print that, we just want a hard return. We don't want to run, we don't want to do anything else, so we're just going to return 1. I'm returning 1 because I made this an int. If you made it a void, I think you could just hit return. Anywho, so we're going on. So we can do some quick tests real quick. Let me just put, I shouldn't delete that hello world, I guess. So this hello world's only going to print if they only enter one letter. So let's make it, oh shoot, I have a lot of mistakes. Error expected. No, I think that's right. String argc. Let me see. Oh, I think my issue is I just never, I had an int instead of an if, so that's on me. So this should be int argc instead of if argc. If argc instead of int argc. Blech. Okay, cool. So let's try this again. So we've got Caesar. Let's enter don't run this. Prompts me with the usage. Let's enter just a 1. Cool. So this part is now working. So we're reading in an argc letter, and then we're giving them an error if it's more than that, and we're continuing on if it's exactly 1 letter. Sweet. I'm actually going to just comment that out in case we need it later. But now, so we know they're entering only 1 variable here. So we're going to read this out. And I'm going to make just a variable called entered string to see what they're pulling out. The end goal of this is to pull out a number, but at this stage we actually don't know if it is or not because we are asking them to insert a string. So this could be anything. It could be strictly numbers like we want, or it could be letters. So now that we have this, we want to iterate over every variable, or I'm sorry, every index inside the string, and if there's a letter, we don't want to use this because we want this strictly to be numbers. Let's just do a simple for loop to go over that. I'm going to use the string library and just use string length instead of actually coding that out. Okay, so this is going to go over every index of the string. So here we can just run isDigit, which if you read the man pages, it's saying that it just checks to see if it's a digit instead of a letter. And in this case, we want every index of this array to return a 1 when I enter isDigit. isDigit returns a 0 if it is not a digit, and a 1 if it is a digit. So I'm just going to say entered string I. So every single one of these should return a 1. So if it enters a 0, that means this is wrong, and I need to print that same error thing that we had here. So I'm just going to print Caesar and return. Cool. So this is saying, hey, we've got this string. Let's go through every single portion of the string, and if any of them are is not a digit, print this and return. So let's try this again. I'll save. Let's do make Caesar. Cool, it actually passed. Let's enter, don't run this to make sure our first thing still works. Yep. Let's enter a, let's say like ERF. Random text, not a number. Cool, tell me that's wrong. Let's enter 1, 2, 3. Awesome, I displayed that number. And then actually, since we now have a number to display, I'm going to change this hello world thing to actually display that number. So this is going to now be that entered string. So this is, if it just makes it down here, it's going to print out the string they entered. So let's go make this again. Oh, sorry. As of right now, it's a string. Alright, 1, 2, 3. Cool. 5, 5, 5. Awesome. So you get the idea. Cool. So now we know at this stage that they've only entered 2 arguments, and the second argument, they enter a string, but we know by line 26 that anything they entered is strictly digits. Since we know this, we can use the function they talked about in the walkthrough. It's this A2OI. For those unfamiliar with it, read the man page. It generally just converts a string to an integer. So at this point, we know that's safe for us to use because we just checked to make sure everything they have there is an integer. So I'm just going to call it int key. I think that's what the lesson called it, so I'm just going to steal their variable names. So int key is A2I entered string. And I'm going to check this by then printing, because it should now be a number. I can use the %i, and I'm going to print what they enter. So let me try this again. So I'm going to make Caesar. I'm going to run Caesar with, let's say 1, 2, 3. Cool, it prints it. I forgot my new line character, but that's fine, we know it's printing. So now anything they entered, we verified it's a number, and we're printing that out. So now we're at the point, so all this is done. So we're now assessing the string, accessing the key. Sorry, I'm trying to rush through this because I'm really hungry. And anywho, so we're going through here. They have success written out. You don't really need to do that. You'll end up deleting it before you actually submit it. But we are now at the turn where we ask them for the string that we want to pass in. So this plain text thing. So now I'm just going to call out for a string. So I'm going to create a string called plain text, and then use the CS50 library get string to ask them to enter something. And all my stuff's weirdly off. So plain text, the string plain text is going to hold what they entered. We don't really have to error check this because what we want to do is go through the string they entered in any letters. So any numbers don't matter, spaces or punctuation doesn't matter, but any letters we then want to move them up the amount listed in the key. So to do that, let me make sure that their string actually worked. So I'll do a print string. Printfs, always super helpful, definitely, at least in this stage. You know, anytime you need to check a letter or a variable, that's definitely a good way to go. And it doesn't seem like this, because I can't spell. So make Caesar. Let's make it just a 1, so we see the 1. Let's enter hello world, prints out hello world. So we're getting the string they want, cool. We know the key's working, and we know the string's working. So what I'm going to do is I'm going to leave the variable plain text there. That way I always know if I need to go back to what they entered, I have that available. And instead, I'm just going to make a copy of that string called ciphertext. And I set that equal to plain text. So this should just take anything they enter and print it out under its new name. And then actually I can get rid of these comments because they're not needed. Ciphertext. Let's see, formatted. Oh, because I use $sign instead of %. Cool. And then I'm actually going to copy this because I know we will need this later. I'm just going to do all our math down here before we do that. So my idea is that we just simply modify our now ciphertext string and do with it what we want to do. So the logic here is we only implement letters. So kind of copying what we did up here where we go through the string and check if everything is a number, we now want to go through the string and see if anything's a letter. So we can make another for loop. We still have the string length function from before. So we'll just do that and iterate through the ciphertext. And then if it's a alpha character, and once again they go through this here in the CS50 manual, one, if you want to be a software developer, one thing I get used to is reading manuals. Seems like we're always either writing or reading documentation. So they have this function called isAlpha. Basically, anything you send in, if it's an alpha character, it'll return a 1. If it's anything besides an alpha, it'll return a 0. So we can just create a if statement here. If alpha ciphertext the 1, so the variable we're currently on. You could set this to equals 1. Additionally, 1 is equal to true in C, so you can just leave the statement as this. And if it's an alpha character, it's going to go down here. And just to check to make sure it goes here, I'm just going to print anything they enter. So just a quick check for me to make sure that this is doing what I want. I'm going to make Caesar real quick. I can't figure out how to work parentheses. Make Caesar again. And then let's pass in Caesar with a combination of let's enter our plain text as a combination of letters and numbers, and it should only print the number or the letters out of there. So let's say like 1A, 2B, 3C, and I expect it just to print A, B, C. Sweet. So it's doing that. It's doing what we expected. So now here comes the tricky part, and the walkthrough kind of goes through it, and this is just kind of background knowledge on C. Is C uses the ASCII table There's something called, I think it's called arithmetic math, or I'm sorry, that's not right, string word math. I don't know. I don't remember the exact name. But basically, as with computers and in C, everything is a number. So here on the ASCII table, an uppercase A equals 65. A lowercase a equals 97. And everything that's in uppercase is between the ranges of 65 and 90. And anything in the lowercase is between the ranges of 97 and 122. So when we do our math, it's kind of handy to just keep that in mind with what's going on. So if we move back here, the thing that's going to change this is we have to do separate math depending on if it's an uppercase or a lowercase. So here in this if statement, if they reach here, we know the current index is a letter. So here we can do an if statement to decide if it's an uppercase or a lowercase letter. Once again, there's actually a formula for this in C-type. So there's a is lower. So I'm going to use that. So I'm going to make is lower. I'm going to pass in the current index of ciphertext we're looking at. So if this is lower, I want to make sure this is working. So lower character. And put this here. Copy this because I'm actually going to make another function down here. I'm just going to use an else statement because we know if it's here, it's a letter, and if it's not a lowercase, just by knowing characters, we know it must be an upper character, an uppercase character. So this should test that if I can type letters at all. Cool. So I'm going to make Caesar again. Oh, I use ciphertext instead of cipher, so I'm just going to copy and paste that down here. Oh, and I did that there too. Add that semicolon. It's really good to kind of make in small steps, so as you're going through step by step, always running make, because as you can see, if you're anything like me, I can't type, so it's nice to just fix as I go. So I'm going to make this a combination of upper and lowercase numbers, so let's do a Z, BY, CW, or X. So this should just print those out as either an upper or lowercase. Cool. So we know this is upper, or is lower, and is upper is working. Delete this. So let's do the math here. So since we're going over every letter, we want to, and we're already in the ciphertext, we want to rewrite or modify the current letter that we're on in the ciphertext. And for this, we are going to take, the math for this is kind of tricky, but basically, if we come over here and look at this, we are going to take our current letter. If it's a lowercase, we're going to subtract by A. Lowercase a, so that should make it, if the letter is a lowercase a and we subtract it by a lowercase a, or 97, that'll make it 0. From 0, we can then add the key and do the modulus operator of 26, so any number that's above 26 we will get that. So if I enter, if the original letter is A, and I enter 27, we will get a little a, subtract it by a little a, so it'll go to 0. We will add the 27, so this number is 27, but then when we mod 27 by 26, we'll get a 1. So that'll be a B. So we can do the regular stuff right now and then come back for the modulus, because that's a little bit trickier. So we can just make this ciphertext. I should just copy this to make sure I don't have any spelling mistakes. Ciphertext minus little a, which is 97. So either way you want to do it, plus key. And that's going to mean if we enter an A, we're going to subtract a little a to make it 0. If we plus the key, if we add a key of 1, that's now going to be 1. So to get it back to where it originally was, we have to add that 97 back, or in this case, a little a. So here we can add this little a back. And I'm going to take this formula and do the same here, but this is now going to be big A. And the reason I'm using these letters are, once again, because that's the first letter of this alphabet, and in C, these letters correlate to numbers. So big A will be 65. So anything here in the uppercase alphabet from 65 to 90, I will want to subtract that 65 out of. So now, if I come down here, I still have that print ciphertext. This should go through. Anything that's a letter is going to find out which letter it is, and is going to do this formula against it. And then it's going to modify that letter to be what I want. So we can actually printf. We can watch it get switched. I'll just do %C. Print out the ciphertext. And then I'm going to do the same down here. So when I go through this, you will see every lowercase letter be switched. So let's make Caesar. Let's just send in a 1. So any lowercase a, after it runs this formula, should be a lowercase b. 2 would be C, etc., etc. So let's pass in a 1. Let's just say A, B, C. So we can go through, we can see A. Actually, that's a horrible example. Let me redo that. Let me make just an A. Oops, sorry. 1 and then A. So A, this A is up here at line 39. And the B is at line 41, and then it's returning this. The bottom one is being printed at line 50. So we know the math is working for A, little a. So since it's working for little a, I can kind of assume it's working for big A. To test this, I'm going to remake. I'm going to run through an A, and let's make it A, B, AA, BB, CC. So this should just come out to be the opposite, BB, CC, DD. And we can see that the uppercase switched to an uppercase, 1 more down, and the lowercase switched to a lowercase, 1 more down. Sweet. So we know this is working. If I went up and I ran the test, I don't actually remember what that is. Let me take this. So this is going to work, but it's going to blow up on anything bigger than, if I enter a number bigger than 26, because we don't have the modulus operator there yet. As this tests. Cool. So all the stuff, when they enter something less than 26 a key, seems to work. Anything above 60 or 26 seems to break. It's saying this is not a valid ASCII text, and so that's just saying when we did this math, because they entered, ooh, if I can get back to it, because they entered a 26, it went off somewhere here in the deep end. So 66 plus 26, you know, it's probably, I don't know, a caret or a bracket or something that we can't see correctly as a letter. So to go in there, we talked about this kind of earlier, we just want to take this number before we add back the little a, and we just want to modulus 26. So now anything above 26 will get moved down to be a less than 26 because there's only 26 letters in the alphabet. So now if I make Caesar, let's just add in a 1. Let's call it A, little a, big A, and then here, hold on, actually, let me switch this up. So now let's make Caesar, and I'm going to pass in a 26. Actually, I'm just going to pass in a 60. Oh, shoot. Make Caesar. I want this Caesar dot 0, and then pass in a 60. And I'm just going to enter A. And this came out as I. So let's do this with, let's say 26. A, which makes sense because we're running a modulus of 26 against a 26, so that will equal 0. I could do this again with a 27, and this should increment both these A's by 1 to make it B. Sweet! So I think we fixed the issue. I'm just going to make real quick and then run the tests. Maybe. No whammies. Hey! So it passes all of the tests. So this is now working code that passes all the tests, all the main ideas. I would love it if you all came into this and made functions around this to maybe make it a little bit prettier. I can see right off the bat that this code, you could make a function. You could handle all this in a function. So say like just pass it a bool of true false and make that bool is lower. So the function you're calling would know if the letter you're passing it is an upper or a lower case. You could alter the text they sent in and put all this in a string to pass around the string that they're submitting. You could put this error checking in a method so you know hide this all out and just put like is valid input. So I think there's lots of different ways you could reformat this to make it cleaner. This is working code, and I will let you all see what you can do with reformatting. So I hope you find this video helpful. If not, give me feedback on ways to make it more helpful, and I hope you all continue to do well. Alright, take care.